So the first question is, the application development team in a company have developed a Java application and saved the source code in a .war file. They would like to run the application on AWS resources and are looking for a service that can handle the provisioning and management of the underlying resources it will run on. Which AWS service should a solutions architect recommend the developers use to upload the Java source code file? You have got 4 options. This is your option 1, this is your option 2, this is your option 3, this is your option 4. You have got 10 seconds time to answer the question and your time starts now. Time up. Now let us analyze the answers. Option 1, AWS OpsWorks is incorrect because AWS OpsWorks is a configuration management service that helps you manage and deploy applications, but it's not the best fit for uploading and running a Java application from a .war file. So option 1 is the wrong answer. Option 2, AWS CloudFormation is incorrect because AWS CloudFormation is an infrastructure as code service that helps you create and manage infrastructure resources, but it's not designed for uploading and running application code. Okay, so AWS CloudFormation is also the wrong answer. Option 4, AWS Code Deploy is incorrect. Also incorrect because AWS Code Deploy is a service that automates code deployment to EC2 instances, but it requires you to manage the underlying resources yourself. It's not a full service platform like Elastic Beanstalk. Finally, we come to option number 3, which is AWS Elastic Beanstalk, and this is the correct option because AWS Elastic Beanstalk is a service that allows you to upload your application code, which is in this case a .war file, and automatically provisions and manages the underlying resources such as EC2 instances, RDS databases, and like more. It supports Java applications and is a great fit for this scenario. Okay, this is why we have chosen option 3 as the correct answer. Got it? Let us move to the next question. A big data analytics company wants to set up an AWS cloud architecture that throttles requests in case of sudden traffic spikes. The company is looking for AWS services that can be used for buffering or throttling to handle such traffic variations. Which of the following services can be used to support this requirement? You have got 4 options. This is option 1. This is option 2, this is option 3, and this is option 4. Okay, you have again got 10 seconds time to answer the question. Your time starts now. Time up. Now let us analyze the answers. Option 1, Amazon SQS, Amazon SNS, and AWS Lambda. Okay, so this option is incorrect because while Amazon SQS, Amazon SNS, and AWS Lambda, they're great services for handling message queues, notifications, and serverless computing, they are not the best fit for throttling requests in case of sudden traffic spikes. So option 1 is not the correct answer. Option 3, Amazon Gateway Endpoints, Amazon SQS, and Amazon Kinesis. This option is also incorrect because Amazon Gateway Endpoints are used for private connectivity to AWS services, but they aren't designed for throttling requests. So option number 3 is also the wrong answer. Option 4, Elastic Load Balancer, Amazon SQS, AWS Lambda, these options these are also incorrect because Elastic Load Balancer is used for distributing traffic across multiple EC2 instances, but it is not designed for throttling requests. While Amazon SQS and AWS Lambda are useful services, they aren't the best fit for this specific requirement. So wrong answer. Now coming to second option, Amazon API Gateway, Amazon SQS, and Amazon Kinesis. This option is correct because Amazon API Gateway is a great service for handling API requests and throttling traffic. It can be used in conjunction with Amazon SQS for like message queuing and Amazon Kinesis for real-time data processing to handle traffic variations. Okay, so option number 2 is the correct answer. Let us move to the next question. Okay, you would like to mount a network file system on Linux instances where files will be stored and accessed frequently at first and then infrequently. What solution is the most cost effective? You got 4 options. This is your option 1, this is option 2, this is option 3, this is option 4. Okay, now you have 10 seconds time to answer the question and your time starts now. हुई कजरा रे पितनत 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 पितनत. Time up. Now let us analyze the answers. Option 2, S3 intelligent tiering. This option is incorrect because S3 intelligent tiering is a great solution for automatically optimizing storage costs based on access patterns. However, it is an object store, not a file system. So you would need to use an S3 compatible file system or modify your application to use S3. So option number 2 is the wrong answer. Option 3, Glacier Deep Archive. This is also incorrect because Glacier Deep Archive is a low cost storage solution for long term data archiving. However, it's not suitable for frequently accessed files and retrieval times can be for several hours. So option number 3 is also wrong answer. Option 4, FSX for Lustre. FSX for Lustre is a high performance file system solution, but it's more expensive than EFS IA and is designed for high performance computing workloads, not infrequently accessed files. Okay, so option number 4, FSX for Lustre, is incorrect. Option 1, EFS IA. This option is correct. Why? Because EFS IA, which is like infrequent access, is a cost effective storage solution for files that are accessed frequently at first but then infrequently. You only pay for the storage you use, and the infrequent access tier is cheaper than the standard tier. Got it? This is why our option number 1, which is EFS IA, is the correct answer. Okay, let us move to the next question. A media company has its corporate headquarters in Los Angeles with an on-premises data center using an AWS Direct Connect connection to the AWS VPC. The branch offices in San Francisco and Miami use site-to-site VPN connections to connect to the AWS VPC. The company is looking for a solution to have the branch offices send and receive data with each other as well as with their corporate headquarters. As a solutions architect, which of the following AWS services you would you recommend addressing this use case? You have got 4 options again. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. You have got 10 seconds time to answer the question and your time starts now. Time up. Now let us analyze the answers. Option 1, software VPN. This is incorrect because software VPN is not a native AWS service and it's not the best solution for connecting multiple branch offices and a corporate headquarters. So option 1 is the wrong answer. Option 2, VPC endpoint. This is also incorrect because VPC endpoint is a service that allows you to create a private connection between your VPC and another AWS service such as S3 or DynamoDB. It's not designed for connecting multiple branch offices. So option number 2, VPC endpoint, is incorrect. Option 3, VPC peering, is also incorrect because VPC peering is a service that allows you to create a network connection between 2 VPCs. However, it's not designed for connecting multiple branch offices and a corporate headquarters in a hub and spoke model. So option number 3 is the wrong answer. Okay. Option 4, VPN Cloud Hub. This option is correct because VPN Cloud Hub is a service that allows you to create a hub and spoke model for connecting multiple branch offices and a corporate headquarters. It enables you to create a central hub that connects to multiple spokes, which means branch offices, allowing them to communicate with each other and the corporate headquarters. Okay, this is why option number 4, VPN Cloud Hub, is the correct answer. Got it? Let us move to the next question. This is going to be the last question for this video. Okay. So, a legacy application is built using a tightly coupled monolithic architecture. Due to a sharp increase in the number of users, the application performance has degraded. The company now wants to decouple the architecture and adopt AWS microservices architecture. Some of these microservices need to handle fast running processes, whereas other microservices need to handle slower processes. Which of these options would you identify as the right way of connecting these microservices? So, you have got 4 options again. This times the options are not fitting in the screen. It's difficult to navigate, so if you want some more time to answer this question, you can take your time by pausing the video. Okay, this is option 1, this is option 2, this is option 3, and this is option 4. Now I'll start the timer. Time up. Now let us analyze the answers. Option 1, add Amazon Event Bridge to decouple the complex architecture. This option is incorrect because Amazon Event Bridge is a service that enables you to connect your applications with data from a variety of sources such as AWS services, SaaS applications, and your own applications. While it can help decouple architecture, it's not the best fit for this scenario. So option number 1 is not correct. Option 2, configure Amazon Kinesis data streams to decouple microservices running faster processes from the microservices running slower ones. Okay, this option is incorrect because Amazon Kinesis data streams is a service that enables you to collect, process, and analyze real-time data streams. While it's great for handling fast-running processes, it's not the best fit for decoupling microservices with different processing speeds. Okay, so option number 2 is also incorrect. Option number 3, use Amazon Essence to decouple microservices running faster processes from the microservices running slower ones. This option is incorrect because Amazon Essence is a messaging service that enables you to decouple microservices, but it's more geared towards event-driven architecture and notifications. It's not the best fit for handling different processing speeds. So option number 3 is also the wrong answer. Option 4, configure Amazon SQS queue to decouple microservices running faster processes from the microservices running slower ones. This option is correct because Amazon SQS is a message queue service that enables you to decouple microservices. It's a great fit for this scenario because it allows you to handle different processing speeds by the first point is decoupling microservices running faster processes from those running slower ones. It also allows microservices to process messages at their own pace, and it also provides a buffer for handling sudden spikes in traffic. Okay, this is why option number 4 is the correct answer for this question. Okay, hope you understood. That was it for today's session. You have successfully answered 5 questions today. Congratulations for that. If you like these questions, please make sure to leave a like and subscribe to AMG Cloud for more such videos. We have more questions like these for AWS Cloud Practitioner as well, so you can go check out the playlists. There's one for AWS Cloud Practitioner, one for AWS Solutions Architect. That's it for today's video. I'll meet you in the next video. Till then, keep learning, keep practicing, and keep exploring. Thank you and bye-bye.